Here we can see we've just started the vehicle and we are in open loop. Therefore, all of the sensor readings just result to a default for fuel trims. Here we are in closed loop. We can look at the O2 sensors and how they are affecting our fuel trims. As you can see, our upstream is switching and our downstream measuring catalytic efficiency. As we can see, our short and long-term fuel trims are about normal, as the long-term is adjusting to make our short-term as close to zero as possible. Here we can also see our engine load and our MAF sensor as we give it throttle. We can see how the air intake is increasing. And we can also watch our throttle position and our map sensors to indicate engine load. As we can see with our unmetered air leak after the MAF sensor, the engine has created a lean condition. There, the fuel trims, you can see a 34% long-term fuel trim is adding lots of fuel, try and correct that lean condition created from the unmetered air.
So here in the Equinox, we have shown our air-fuel ratio equivalents, our injector duty, and then our two L2 sensors and short-term and long-term fuel trims are going to be causing a rich condition with propane, and we can see that change here. Yeah. With the propane being induced, you can see our short-term fuel trims go down to negative. All right.
One of the smartest techs here at SIU.
Yeah. So you can see it cut all the way down in our O2 sensors, getting longer. It's going to cause these to pull fuel. And then come back to normal here. So now I unplugged the ETC sensor. Here you can see our temperature is reading -40, and let's see what our fuel trims would look like when we start the vehicle up here. So here you can see our long-term fuel trim. It's going to start going down. Our short term is going to start going down. And our fans are on constant since the sensor is unplugged. And here still trying to get it close to zero, and let's see what happens when we blip the throttle. So as you saw in our long-term fuel trim, our percentage is going to go up. Our fuel trim is going to go up, and our short-term fuel trim is going to try to stay close to zero.
Here we are looking at the catalytic converter temperatures. We take a measurement at the inlet and outlet of the catalytic converter every minute for 10 minutes, and then after 10 minutes held the vehicle at 2500 RPM and continued taking temperature readings. As you can see, light off appeared to begin around 475, around 10 minutes there, and then the outlet began about 10% hotter than the inlet, which is as it's supposed to, as the
catalytic converter lit off, and as you can see how it warmed up through the 15-minute range, and it's fair to say it would have continued to heat up at more operation.
So here we got the vehicle at operating temperature, and we took a temperature reading of every foot on the exhaust system. So at our exhaust manifold on the engine, our temperature was around 552 degrees. And as we start going down our system, pre-cat and post-cat, it's going to be around 470 to 490 degrees. And after post-cat, we start going down through our exhaust system. So after 1 foot after the cat, it's around 270 degrees. And there is a second cat, like a secondary catalytic converter. So it heats up a little bit before going into the cat, and it heats up after.
Here is normal operation of the Buick. You can see we are at operating temperature and in closed loop. As we can see, our map sensors, throttle position sensors reading normally. This is normal operation. Then we can see we're in closed loop, and we can see our upstream and downstream oxygen sensors switching. And we can see our short and long-term fuel trims adding a little bit of fuel. We can also see our crank position sensors there, and our cam position sensor. Here we have our decade box attached to the ECT, and there we can see how it's reading 62 degrees Fahrenheit and operating at normal condition. When we increase our resistance, we can see how it is now reading the coolant at 46 degrees, and we can go even more, about 41 degrees. And with that change, you can see how different sensors will be reading differently. As we can see, we're in closed loop, and we can see our fuel trims. If we add even more resistance, we can increase even more. 9.5, reading at freezing. And there we can also see how it's changed our sensor readings, including our fuel trims and other readings. We can also hear a audible change in how the engine runs as idle increases at a colder temperature. Now if we take the decade box and lower resistance below operating temperature, we can read, we're reading more hot, and we can continue this. Drastically, so we're reading very hot now at 140. And we can continue until it thinks it's very hot. As you can hear, it lowered idle at above operating temperature, and we can see how it has affected sensor readings, including our fuel trims. You can see short-term fuel trim change drastically there. Now we can see with very little resistance at the ECT, the sensor is reading very hot, that it's overheating, and we can also see how that's changed our data. As you can see, our pulse width's changed. Our O2 sensors are still switching, but our fuel trims have lowered drastically.